Hello everyone, today we are going to continue our talk of trigonometry and talk about what is referred to as the law of sines. Now, the law of sines is a very helpful law that allows us to find missing angles and missing sides, just like we've been doing through a lot of trig, but it works specifically in any triangle. Okay, now we do have to have certain information in order for it to work, but it works in any triangle. So let's start by figuring out what the law of sines is, and then we'll talk about kind of why it works. So, in any, and any is really important here, triangle ABC, which is just giving me my letters to use, the sine of A divided by A, little a, is equal to the sine of capital B over lowercase b, which is also equal to the sine of capital C over lowercase c. Okay. Now, quick note here before we go too far. In this notation, opposite sides and angles are given the same letter. Okay, the only difference is that angles are given capital letters, so I could call this A, B, and C. That's my triangle A, B, and C, which means little a is going to be the side across from A, little b is the side across from B, and little c is across from big C. Okay, now that's important because those matter than where they show up in this law of sines. So what law of sines does basically says if I take the sine of the angle and divide it by the side across from it, or opposite it, that's going to equal the same thing as dividing any of the other angles by the side opposite of them. Now, the way this is written, it actually uses 3 fractions, but whenever we solve this, we'll only ever use 2. So I might not have this one here, which means I have a proportion. I have 2 fractions that are equal to each other, which we know how to solve from our similar triangles unit. So, let's talk about why we actually need the law of sines. So, up to this point in trigonometry, we started with our special right triangles, which means we could only solve triangles that had angles of 30, 60, or 45, or 90, I guess. But it was specifically those angles. We then used those to start to come up with what we called SOHCAHTOA, which then allowed us to go to any right triangle. So we were still stuck to right triangles, but we could have any of the other angles and sides that we wanted. Then we went to the unit circle, where we still stuck to right triangles, but we went beyond 90 degrees and started to find some of those other measurements in between as well. Now what we're going to do is we're going to go to any triangle, and that word here, any, is really important because we can literally figure this out for any triangle, assuming that we do have what we need. So let's talk about what we need. This is going to be used for us to find missing angles and sides. Missing angles and sides when given a complete pair. Okay, and what we mean by a complete pair is the fact that we know both an angle and the side across from it. So in order to make this work, I have to have an angle and know the side length that's directly across from it. That's going to make my complete fraction. The other one, I'm going to need to know the other half of what I'm trying to find. So if I'm trying to find the angle, I need the side that's across from it. If I'm trying to find the side, I need to find the angle that's across from it. So essentially, there are certain requirements that we do still need. This won't work in completely any triangle, but nothing specific about the triangle has to be true. I just have to have the right information. Okay. There is another law that we would use to talk about things without complete pairs. It's what we call the law of cosines. We're not going to get into that video, but that's going to basically take care of anything where the law of sines doesn't work. The law of cosines would. Okay. So we've kind of talked about everything here. I'm not going to go too far into where this actually comes from. If you really want to know where it comes from, you can look it up or email me and I can send you a video of it as well. I'm not too concerned about that. We need to focus more on how do we use it and how do we get those missing sides and angles. So let's start with a couple examples here. I'm going to start with number 1. We're going to start by finding the length of DF. Now, I'm not going to actually refer to this as DF. I'm going to refer to this as X. Now, I could also use the letter E because it's across from the angle E. Okay, but I'm going to use X just so it's one thing that I'm trying to solve for. Okay, the other thing I have to look for is I have to make sure I have a complete pair of a side and an angle across from it. So the only side I have is the 18, and across from the 18 is the angle of 105. So I do have my complete pair. That's right there. I can then use my 32 is across from my x side that I'm trying to find, which is important. I need to know the angle that's across from it. Now, let's say I did ask you for the side DE instead of DF. Well, I know two angles, and I'm trying to use the other side that I don't know the angle to. I can find this angle by simply subtracting these two from 180. So just because you don't have the right information given to you doesn't mean you can't find it. There are some cases you aren't going to be able to, but in this case I could find that other angle if I needed. But in any case, I have what I need for this one, so let's go ahead and get this set up. I'm going to always start with my complete pair. So I'm going to start here with the sine of my angle, which here is 105, so sine of 105, divided by my side length, which is 18. Okay, I'm going to set that equal to another fraction with the sine of an angle. Here I'm going to use the other angle, which is 32, divided by the side across from it, which is the one I don't know, which is x. So what I've just set up here is the first part of my problem that I'm going to have to solve. And this is really important to know what this is going to look like. In this format, you are always going to have sine on top. Okay, that's part of the law of sines, that sine always shows up on top. Then I have my angle measures inside of those. I need to make sure my pairs are set up so that they're with each other. And I need to make sure I have one piece that's missing and I know everything else. If I have two missing pieces, it's not going to work. I need to have at least one to solve for. So let's think about how we solve this now. Well, I have two fractions that are equal. If you remember back to our similar triangles unit, that means that I take and I actually cross multiply these. So when I do that, I'm going to jump down here to the bottom. I'm going to have x times the sine of 105. And I'm going to set that equal to the other side, which is going to be 18 times the sine of 32. Okay, now, I could go ahead and start to simplify this right-hand side, but I'm actually not going to because I want to keep this answer as exact as possible. I don't want to round too early. In fact, I'm not going to round until the very end. So what I need to do is get x by itself. X is being multiplied by the sine of 105. Well, the sine of 105 is just a number, so the way I get rid of that is I divide by the sine of 105 on both sides. And I have that x is going to equal 18 times the sine of 32 divided by the sine of 105. Okay, now, this part that I just wrote here is not necessarily work that you need. Everything else up to this point I do need to see as part of your work. So this is one where it's going to be really important to show everything. But I do need to get my answer here. So let me grab my calculator. Let me show you two different ways that you could type this in. So I'm going to first show you how you could type this in all at once. I want this whole top part to multiply first. So I'm going to put it in parentheses, multiply by the sine of 32. Now I have two open parentheses, so I have to close it twice. Then I divide by the sine of 105, and I close that parenthesis. And now those parentheses are really important because what can happen is if you forget them, now you're dividing a sine inside of a sine, and that goes crazy very quickly. So I hit enter here, and I get 9.875. I'm going to go ahead and write that down. Okay, now I didn't go completely to the end of that decimal because for most of these, I'm going to ask you simply to go to one decimal place. So I'm going to call this 9.9. Okay, now, before I go too far, I do want you to always check and make sure that these answers are reasonable. If I go back to the side length that I knew 18, and that's across from 105. So that's got to be my biggest side, so I know I need to be less than that, and I definitely am. Okay, now, you can't go much further than that as far as is it bigger or smaller than what it needs to be. Really what it comes down to is I wouldn't want an answer here anything above 18 for sure. But there are different mistakes that you could make that could give you answers like that, and I want you to be able to check those and see those mistakes. Okay. Let me go back here, though. I do want to show you the other way you could type this in. Basically, it's doing it in two parts. I would do the 18 times the sine of 32, and then I hit enter there. Now, this is my number. Excuse me. But I need to divide this by the sine of 105. Before I round this or anything, I'm just going to simply hit divide by the sine of 105. So I'm letting the calculator store that number so I don't have to write it down. When I do that, I then get down to my same answer. I would round the same way. Okay, but you got to be careful because if you're round early, your answer's going to end up off a little bit and you're going to lose points. Okay, so that's finding a missing side. Let's talk about if I have a missing angle, because this one's going to look a little bit different. Okay, first thing I need to make sure is, do I have a complete pair? Well, here I have the 75 and the 7, so I definitely have that complete pair. And I'm asked to find angle S. Well, angle S is the side across from the 5, so I have the other piece of information to go with the side that, or the angle that I'm trying to find. Now, just real quick here, if I gave you this information and asked you for angle R, what I would do is exactly what I'm doing here. I would find S actually first, then you do your 180 minus your two angles. Okay, so you can still find all your angles. You just have to start by finding S because that's the information I'm given with the 5. So let's go ahead and get this thing set up, and then we'll talk about how we're going to solve this one. So again, I always start with my complete pair. So I'm going to start with the sine of 75. That gets divided by the side across from it, which is the 7. Then I set that equal again to the sine of my angle. Now here I don't know my angle, so you can either use the letter. I'm going to use the letter S, which I know gets a little bit confusing with 5s and whatnot, but I'll call that an S. You could put a theta in there as well, or an X, whatever you want, something to hold the place to know that's what I need to find. Okay, now, before I go any further, if you remember back to SOHCAHTOA, I said that anytime you are solving for an angle, you have to use an inverse trig function. That still applies here. Anytime that you see you're trying to find an angle, I know that at some point I'm going to have to take an inverse of a sine, or this isn't going to work. So I just have to keep that in the back of my mind. I'm going to have to use an inverse at some point. Okay, but for now we can go ahead and start to solve this. So I'm going to cross multiply. I'm going to do 7... Actually, we'll do this one first. 7 times the sine of S, and then we'll multiply 75 by the 5. Sine of 75 by the 5. So, again, that's 7 times the sine of S is equal to 5 times the sine of 75. And well, I need to get to S, so I need to get the 7 out of here. Let's go ahead and divide by the 7. Okay, and I get that the sine of S, big S here, is equal to 5 times the sine of 75 divided by 7. Well, now that I have sine by itself, the only way to get rid of this sine is to take my inverse. So what I'm going to say here is that the S is going to equal the inverse sine of everything I just did here. So this is the 5 times the sine of 75 divided by 7. Okay, now, you got a couple options again. I could attempt to type this all in at once. This one's getting to be a little bit much to figure out where all the parentheses go. So I might try to just do this inside part and do the same thing I did with the second method from number 1. Just let my calculator store that number. So let me go ahead and show you how that might look. So on my calculator here, I'm going to do 5 times the sine of 75. Okay, and then I'm going to take and hit, you can either hit enter now or just simply divide by 7, as long as you have closed that parenthesis. If you haven't closed the parenthesis, that's not going to work. Okay, when I do that, I get this number. Now, you could write down this number, and it would look like you're still taking the inverse sine of that, so inverse sine of 0.6899. Now, even if I write down 0.6899, you need to make sure you use the entire decimal that's in here. Okay, because again, using too little of these is going to take your answer too far away from what it needs to be. So let's take the inverse of that. Again, second sine is how I get to the inverse, and then I can do second negative gives me the answer to bring in that piece again. Okay, hit enter, and I get an answer of 43.6 degrees. Okay, now depending on what my directions are, I'm rounding here to the nearest tenth. Okay, but it may say round to the nearest degree, which would make it 44. Kind of just depends on the directions. Just follow whatever the worksheets or quizzes you're working on say. We'll make sure that's clear on all of those. Okay, so here's my answer for that angle S. Yeah, which again, based on the picture, I can see 5 is less than the 7, so my angle that's across from it needs to be less than the 75. I definitely am. That's really all I can say about that one as well. Okay. Now, at this point, I'm going to continue and do 2 more examples. These examples are going to be very similar to what we've already done, so if you feel pretty confident at this point, this is going to be the rare time I can tell you can actually probably stop and go ahead and try some of these on your own. I would also maybe suggest that you try numbers 3 and 4 on your own before I go through them right now, and then come back and watch the video of me going through them and see if you did them the same way. Okay, so if you want to pause the video, I'm going to continue and do 3 and 4. You can do them on your own and then come back and check to see if you got them right. Okay, so I'm going to continue here finding angle R in number 3. So I'm trying to find this angle down here. Okay, I do have my complete pair here with Q in the 28, the 39 degrees and 28. I also have the side across from the angle I'm trying to find with the 41. So we'll set up our function here. This is going to be the sine of 39 divided by 28 is equal to the sine of R divided by 41. If I go ahead and cross multiply, I'm going to have 28 times the sine of r is equal to 41 times the sine of 39. And I'm going to then divide by the 28. Divide by 28, which gives me sine of r is equal to 41 times the sine 39 divided by 28. Okay, again, I'm trying to find an angle, so I do have to take an inverse. So r is going to equal the inverse sine of 41 times the sine of 39, all divided by 28. Sorry, yes, that looks right. I was questioning myself for a second. Okay, then we can go ahead and solve this. Again, I'm going to grab my calculator here. I'm going to show you what this would look like if we do type it in all at once. So I would take the inverse, then in a set of parentheses, I'm going to do 41 times the sine of 39. Now I'm going to close one parenthesis, closes the sign. I need another one to close the top part of that fraction. And then I'm going to divide by 7 and close again, which then closes in the inverse part of it. So now everything's inside the inverse. The 7's on the bottom, and 41 times the 39 is on top. Sorry, this is not a 7. This is a 28. Let's make sure I get the right problem here. Okay, then we can go ahead and hit enter. And I get 67.147. We'll call it 67.1 degrees. Which again should make sense for us. I can kind of look at the picture and see that that's 67, but more importantly, I know it needs to be bigger than 39 based on 41 being bigger than a 28. Okay, so you can kind of use those side links to give you a rough idea of what your answer should be. Next piece here is number 4. Number 4 says find the length of xy. Now xy is over here on this side, so I'm just going to simply call this x. I know it's not technically the side x, but it's the x I'm trying to find. So we'll go ahead and use that. I do have a complete pair here with the 40 and the 12. But now I have an issue. If I'm trying to find side x, I need to know the angle here at z, which I don't technically know, so I got to do a little bit of work to find it. But I can do 180 minus the 40 and minus the 73, which is going to give me a side of 67. So this angle here is 67. And we can now go ahead and try and find our missing side that I've called x. So if I set this up here, this is going to be the sine of the angle we know, which is 40, divided by the side we know, is equal to the sine of the other angle, 67, divided by the side I don't know, which is x. Go ahead and cross multiply x times the sine of 40. It's going to be x times sine of 40 is equal to 12 times the sine of 67. I can then divide by the sine of 40 on both sides, which is going to give me my answer here when I type that into my calculator. So we'll go ahead and type it in here. 12 times the sine of 67. Okay, close your parenthesis there, and divide by the sine of 40. If I do that, I get 17.184616. But again, I'm going to round to the nearest tenth, so I'm going to call this 17.2. And I don't have any units here, so we don't have to put them. If they do tell you units, you should include them. We didn't talk too much about units, but basically units will stay the same. If I give you a side that's in inches, the side you find would be in inches. Any angles are going to be in degrees. We're not going to use radians for our sine, cosine, tangent pieces here. Okay? So that is our video on the law of sines. Again, it's really up here as the sine of A over A, sine of B over B, and sine of C over C. But again, we only use 2 of those at a time depending on what sides we have. Really just take the ones that you need and use those. Okay? If you have any questions on this video or anything that goes along with it, again, if you want to know where this comes from, let me know, and we will get you all situated with all of that.